Section 7 of AS 3533.4.1. This deals with structural integrity, and that's all to do with the blower, making sure that the thing stays inflated. There's a couple of sections to it. The first section says that the blower must be sufficient to make sure that when the heaviest person that the bouncy castle specifies should be on there, it has a maximum weight written on the side, that when that person stands on, the inflatable shouldn't be grounded. We've had that possibly twice, certainly once, when somebody went on, and as they stood on, the inflatable went down to the ground. We ushered them off as quickly as possible. But you can see that that would be a good thing. And of course, it just says it's got to be able to do that under operational conditions. So even when you put lots of people on who aren't all of the maximum weight, etc., it should be able to support those. The walls, etc., have got to be able to support people leaning against them or being pushed against them, etc. That seems fine. And then we have conditions for when you have power loss, for example, or a blower goes down, or there's more case the electricity goes off in the house as a momentary blackout, or perhaps the RCD trips, or somebody just trips on a plug or pulls it out or whatever. The inflatable should then not go down too quickly. It should allow people to escape in a reasonable time. More than that, for slides, it should go down in such a way that it just doesn't fall over sideways or what have you. You've obviously got people at a very tall height, so it's got to come down very slowly. And that's why you have baffles inside the bouncy castles. To stop the air flowing straight out, it has to sort of move through from one cell to another. And it's a pain for me because that means bouncy castles don't go down so quickly, which costs me time when I'm packing away. But you can see the point for it. We once had a slide out at a public event, and something happened with one of the cables. Somebody pulled it and it came apart. I can't really remember. It was a decade-ish ago. And the slide started to come down. Now, I wasn't supervising the slide at the time, but I was kind of off to the side, and there was a couple of us, and we were just watching the slide. And I suddenly went, I think the slide's going down. And we all sat there and went, no, is it? Don't know. And what seemed like ages, but was probably only a few seconds, we were going, I don't know. Then it became obvious the top was starting to crumple slightly. So we rushed over, and the person supervising the slide hadn't quite noticed because they were concentrating on the crowd. We stopped, told the children there wasn't that many on it because that's a point of operation, to come down very quickly. They did. They got off, and then the thing was able to deflate safely while we looked for the cause of what was happening. And that's what should happen with slides. They shouldn't just fall down straight away. It also mentions that the bouncy castle must have some way of preventing backflow. If you've ever been inside a bouncy castle, where the air goes in for a chute, a long thin vent, you will often find inside there just a flap. It's just a flap of material. When the air blows in, it pushes it out and the air goes in. If that stops happening, the flap comes shut and stops the backflow of air. It's not perfect, but it does at least limit the amount of air that can come out in any one go. The blowers themselves usually have flaps on them, so when it's blowing through, the flaps are all horizontal and the air just comes straight through. As soon as the blower isn't blowing, that flap falls down and stops the backward flow of air. They tend to be kind of cheap plastic and often aren't all there after a while, but that's what they're designed to do. The last piece of Section 7 is... I'm going to almost have to read this word for word because it's strange. It says that the designer of the device shall specify the level of inflation, which is fair dues. You could just say, well, that's when they say use a 1.5 horsepower blower or 2 horsepower blower or whatever it's going to be. And the time the device's design allows to effect emergency evacuation. So with each inflatable, the manufacturer should supply the time for emergency evacuation. I don't know any bouncy castle that does that. Along with methods, and this is, I'm going to quote this bit, along with methods for testing evacuation provisions and the frequency of such tests. How to test evacuation procedures and the frequency of such tests. If you're a bouncy castle operator out there, how often do you test to test evacuation procedures from the inflatable? I could understand if this was a large structure in a at a theme park or something where you've got hundreds and hundreds of people on it and it goes up and over and round and all the rest, and you might go, if it goes down, do our staff know to go and get kids out from here, there and everywhere and evacuate, blah, blah, blah. But a bouncy castle in someone's house, testing evacuation provisions, something else that doesn't happen, eh?